Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
This question is asking us that from a molecular viewpoint, where does the energy absorbed in endothermic chemical reaction go? So in endothermic reaction, we have the flow of energy from surrounding to the system. That is, this is energy flow. So when this energy flow from the surrounding to the system, the energy is being reorganized into the arrangements into the products, and that leads to the increased energy of the product relative to the reactant. And when that happens, then the reaction becomes endothermic. So energy flows from the surrounding to the system in the endothermic reaction. And why does the reaction mixture undergo a decrease in temperature even though energy is absorbed? Well, we know that under normal circumstances, that chemical potential energy is as a result of the electrostatic interaction of protons and electrons that compose the atoms, and the atoms makes up the molecule within the system. So in the case of the endothermic reaction, some bonds are broken and others are formed, which is normal for every kind of reaction. So the nuclear material, the proton and the neutron, and also the electron reorganize themselves into an arrangement with higher potential energy, which is the product in this case, and that's as a result of the thermal energy that was absorbed from the surrounding into the system in this case. So the thermal energy that was absorbed from the surrounding into the system in this case goes into increasing the potential energy of the product species relative to the reactant species. So the energy profile diagram will look like this. If this is a reaction coordinate, and initially you have the reactant this way, so I'll call this potential energy. So if this is the reactant right here, so bonds will be broken and new ones will be formed. So the system will absorb heat energy or thermal energy from the surrounding, and that will lead to the formation of products at higher potential energy than the reactant. So we'll have something that looks like this. So if we compare the energy of reactants to the products, of course, we will see that the energy of changing delta H, the change in energy of the product relative to the reactant, is going to be positive because we're going to have a product minus reactant, and this will give us a positive number. So this positive number shows that the thermal energy is flowing from the surrounding into the system. And when that is happening, when the system is absorbing energy, for example, if you put your hand on a system that is absorbing thermal energy, the way you feel it is coldness, because it absorbs heat from your body, and then you feel it as coolness or coldness. And this is very relative to a system called cooling by evaporation, another concept in physics. So if you want to understand more how absorption of thermal energy leads to decrease in temperature of a system, then you need to understand the concept of cooling by evaporation. Okay.